Inside a machine shop in Tatarstan, one routine task near a lathe turned into a deadly chain reaction. It's November 19th, 2020. A 56-year-old worker named Murat was at his station operating a DIP-300 lathe. He's not in protective gear. The long sleeves he wears hang loose near the moving parts of the lathe. Murat leans closer to make a quick adjustment. Without warning, the lathe's rotation surges to life. His loose sleeve flutters near the spinning part, a moment's lapse that turns routine maintenance into chaos. The machine hums to a stop seconds later, a stark reminder that energy never waits for hesitation. Never, ever work near a lathe or rotating equipment without proper clothing and lockout. Always stand clear of the rotation zone and disconnect power before making manual adjustments. In a workshop filled with towering tanks and silent heat, something unnoticed begins to build beneath the surface. At a magnesium plant in Russia, maintenance crews were inspecting a furnace unit used for titanium and rare metal recovery. Around them, massive vertical tanks rise from the floor, each containing volatile magnesium compounds and titanium chlorides. A reaction begins deep within the separation unit, a faint spark inside the furnace chamber. In moments, the glow intensifies, light floods the workspace, and the air ripples with radiant heat. The system shuts down as magnesium ignites inside the vessel, sending bursts of light and vaporized metal upward. Reactive metals like magnesium and titanium can ignite explosively when exposed to air, moisture, or improper cleaning during furnace inspection. Every maintenance procedure in such environments must follow inert gas purging, surface cooling, and strict ignition control before any inspection begins. It looks like a routine weld, a few sparks, a steady flame, but what happens next turns calm steel into a sudden blast. Inside a small repair workshop, a welder is working near an upright metal drum. He positions his torch near the top seam to seal a small leak. No smell of danger, no smoke, just another quick job before the day ends. But inside that closed drum lingers a mix of oil vapors and compressed air, an invisible trap of flammable gases. As the torch touches the drum's surface, the trapped vapors ignite, releasing a burst of pressure that lights up the workspace. The reaction is over in a second, a stark reminder of how sealed containers can turn residual fumes into sudden, uncontrolled force. A simple wall cut on a sunny balcony. But what happens next shows how one slip of a spinning blade can turn control into chaos. On a narrow apartment balcony, a worker is using a handheld wall-cutting saw to carve a vertical line into a reinforced concrete wall clad with small ceramic tiles. To him, this is just routine work, opening a channel for conduit installation. But every condition here is primed for risk: a confined workspace, a wet floor, no grounding protection, and a tool that reacts faster than human reflex. As the saw cuts deeper, the tone shifts. Resistance builds until the blade catches rebar hidden beneath the tile. The tool reacts instantly, its torque reversing in a sharp kickback. The sudden motion throws mud and dust into the air, and the saw spins briefly before powering down. In moments, routine work turns into a lesson on how torque and traction collide. Never, ever cut into concrete or tile without knowing what lies beneath, and never stand in the line of the blade's recoil. When torque reacts, it doesn't wait for you to move. It looked like a simple step across, a few planks over an opening, but what happens next will remind every builder why shortcuts never hold weight. High above the ground, on the upper floor of a building still being framed, workers moved quickly to clear debris and collect tools before the next concrete pour. The space was tight and the floor cluttered with rebar, cables, and temporary boards. In the middle of it all, a large open elevator shaft, only covered with a sheet of plywood just to make it easier to move between sides. It wasn't secured, tested, or rated for weight, just balanced loosely between the edges of the concrete frame. A worker walked across to grab a piece of equipment lying on the far side. A few seconds later, he turned to return. As he stepped back onto the plywood sheet, the tone beneath his boots shifted, a creak, then a sudden give. The board flexed and dropped out of place, exposing the open shaft below. In seconds, the scene revealed how temporary covers can't be trusted to support even routine movement. The board failed exactly as designed because it was never built to carry weight. Never ever walk or place any load over an uncovered or temporarily covered opening. A single step on unsecured material can turn stable ground into a deadly void. It only takes a few seconds, the time it takes to look away, for balance to disappear completely. On a busy street lined with shop fronts, a small scaffold frame stands beneath a storefront sign. On top of that narrow frame rests an extension ladder, angled upward against the purple shop facade. It's a setup born from improvisation. Ladder feet wedged on a thin platform, no base lock, no stabilizer, no tie-off. At the bottom, a worker in a blue shirt steadies the entire structure with both hands, while the other man climbs up to reach the sign. The man above moves carefully, trusting the one below to keep the base steady. It's teamwork built on instinct, not safety. As the climber reaches for the top of the sign, the man in the blue shirt looks away for just a moment. The frame shifts under uneven weight, the ladder tilts, and the structure begins to sway. Within seconds, balance is gone. The setup reveals exactly how quick stability can fail when human steadiness replaces proper anchorage. Every elevated job needs a structure built for stability, not convenience. Never stack ladders on scaffolds. Each tool is designed for separate loads and angles. Combining them removes both their safety limits. Also, never rely on human steadiness as a substitute for engineered stability. Hands get tired, distracted, or let go. Steel doesn't. It looked like a simple highway maintenance stop until one car crossed the cones and everything ahead vanished in an instant. Early morning on an open expressway, traffic flowed at full speed. Sedans, vans, and white utility vehicles moving in steady rhythm. On the left lane shoulder, a small road maintenance pickup is parked with its hazard lights on, towing a trailer-mounted aero board flashing bright yellow chevrons. Around it, two workers in reflective vests move cones into place, creating a taper to divert traffic around the shoulder. But this isn't a closed lane, just a small temporary patch zone without barriers, without an attenuator truck, and without a full buffer distance. The crew relies solely on drivers seeing the lights, understanding the cones, and reacting in time. A gray sedan approaches from behind, its speed steady in the inner lane. For a moment, it tracks straight, then drifts slightly, cutting through the cone line. With no barrier truck or buffer zone in place, there's no margin for correction. In seconds, momentum carries through the work zone, proving how a single oversight in protection can turn space into exposure. Never, ever set up a live lane maintenance zone without a physical protection system. Cones and lights are not shields. Only separation, distance, and barriers stop kinetic energy from turning a work zone into an impact zone. He thought the tank was steady, but when the steel beneath him shifted, gravity took over faster than he could react. Inside a fabrication bay, a massive cylindrical storage tank, still unfinished, rests on two temporary cradles. It's not anchored, not braced, just balanced. On top of it, a welder in blue coveralls works carefully, sparks bursting from his torch as he seals a joint seam along the tank's curve. His boots rested on the rounded shell, his ladder set against the side for access, his fall arrest line clipped overhead to a crane hook, the only thing between him and the floor below. Everything seemed stable until it wasn't. The tank shifts slightly on its cradle. A few inches that change everything. The welder's footing slips across the curved surface, his torch flickers out, and tension ripples through the overhead line. The setup reveals how even minor movement on unanchored steel can turn balance into a moment of recovery. Always secure round or cylindrical vessels before climbing or welding on them. Use certified chocks, wedges, or cradle mounts. The hazard begins the moment you treat a curved, unanchored object as stable footing. What happens when precision meets carelessness, and one wrong reach turns the machine into a trap? Inside a heavy machine shop, a vertical turret lathe dominates the space. A steel giant with a rotating table over 2 meters wide, built to handle massive components. The operator climbs onto the lathe's table just to reach the overhead control pendant. Down below, his colleague watches casually, assuming the machine is isolated. Then, in a heartbeat, the VTL table activates. The rotation surges with full torque. The operator's stance breaks as the polished surface turns beneath him. The motion exposes just how fast stored power can react when isolation isn't complete. a single live circuit turning balance into chaos. A vertical turret lathe is not a platform. It's a live, powered work zone with rotational energy that can activate without warning. Do not stand, sit, or reach across a VTL table for any reason. Instead, isolate power completely, lock out, and position control pendants within reach from the floor or a stable platform. He walked beside the furnace tracks, unaware that above him, a mountain of metal was already letting go. In front of the blast furnace line, a diesel locomotive assistant walks the rail path, checking coupling lines. Above, the slag bay holds tons of compressed metal shavings, stacked and unstable, dried under furnace heat. Everything looks routine. Then the vibration of the moving locomotive shakes the side of the pile. Without warning, the pile shifts. A wave of metallic dust and shavings slides downward, covering the rail track in seconds. Visibility drops to zero as heat and vibration trigger a chain reaction of movement, proof that even a stable surface can turn active without a sound. Never ever walk beneath or beside a loaded slag or scrap pile without verified stability clearance. Do not assume stillness means safety. Dust clouds can hide movement until it's too late. A pile doesn't have to move fast to be deadly. It only needs to move once. Weight, heat, and vibration don't mix. Respect the pile. Keep your distance. Don't forget to share what you learned today in the comments. Your insight could save a life. Take care.